White paper on automatic blowout preventers for eliminating tragedies such as the explosion on board the Deepwater Horizon on April 20, 2010. Prepared by Clint Nelson. White paper outline. Consider conditions leading to kicks. How unmitigated kicks become blowouts. Current safety technology. Industry efforts to improve reliability and performance. The CDS automatic blowout preventer. Inventor background. Consider the conditions leading to kicks. In the process of drilling for oil and gas before the major find, smaller pockets of extreme high-pressure hydrocarbon are opened and enter the wellbore. It is very difficult to know if it is a small pocket, a large one, or the major find. The first line of defense is the drill mud because it is used as a cork. The drill mud is also used to lubricate the drill head and bring rock shavings on board and is closely monitored. The same quantity must come up as is pumped in by the drill pipe, plus the volume of rock dislocated by drilling. Any deviation is significant. A kick is described as a sudden increase in pressure and in the quantity of drill mud entering the well bore. When this occurs, drilling is typically stopped, the drill mud is degassed, and as soon as the kick is mitigated, drilling can resume. The decision to stop drilling is heavily influenced by the cost factor. For example, the cost of operating Deepwater Horizon well exceeded $1 million per day and was more than $50 million over budget. The mixtures contain, in addition to crude oil, methane and other gases such as highly poisonous, deadly hydrogen sulfide under very high pressure. These mixtures rise toward the surface of the ocean, oil rig at speeds that increase exponentially if they escape the well. How unmitigated kicks become blowouts. The kick becomes a blowout if the decision to stop drilling, activate the blowout preventer, or disconnect the equipment is not made timely. If the kick is not stopped in its tracks immediately, once the column of drill mud measuring 25,000 feet in height, with a 24-inch diameter riser alone, at 5,000 feet height, and with a mass of many millions of pounds, not to mention the casing adding a column totaling nearly 20,000 feet, will blow out anything standing in its way as soon as it picks up speed. Off the coast of California in the 60s, a blowout was capable to bust even the ocean floor, BOP and all. This aspect is not properly addressed. I believe that the Deepwater Horizon BOP would have been functioning as designed and activated suddenly. The inertia of the gigantic mass of 25,000 feet of the column of drill mud and oil could have been hammered out the bottom of the ocean, BOP and all, just as it did in California in the 60s, in spite of the fact that the weight of the BOP was well over 300,000 pounds. A pittance compared with the mass of the drill mud in motion. The massive gas blowout in Russia could not be stopped with any conventional methods. In the end, only a nuclear detonation snuffed it out. Until the automatic blowout preventer was invented, no one had a solution for this phenomenon with the potential catastrophic consequences. In fact, on the Deepwater Horizon, even as the blowout was unfolding before their eyes, shooting a sky-high lethal mixture of oil and gases with a mass of tens of millions of pounds blowing through everything in its way and proving to be unstoppable. The emergency button for disconnecting the equipment was not activated until the BP executive agreed. The BOP did not function as intended. In my opinion, even if the BOP would have been working flawlessly, the 24-inch diameter riser pipe with a length of 5,000 feet and containing a high volume of lethal mix of methane and other gases, which were expanding exponentially, would have been enough to blow up the Deepwater Horizon many times over. In my opinion, even if the BOP would have worked flawlessly, the explosion could not have been avoided. But the Deepwater Horizon would not have burned for 3 days, and it would not have sunk the $500 million plus oil platform into the bottom of the ocean, with 11 lives. According to the forensic analysis performed by the United States Chemical Safety Board, the foremost agency analyzing industrial accidents, the solenoid controlling the BOP was wired in reverse polarity to the redundant recoil where the two magnetic fields canceled each other, rendering the BOP's safety feature inoperative. After considering all of the facts, I came to a sobering conclusion. Namely, the current BOPs have a very spotty safety record. Steve Cole, Pulitzer Prize-winning author in his book Private Empire, Exxon Mobil, and American Power, put it this way, writing, drilling any oil well requires managing the risk that trapped oil and gas under extreme pressure in the ground, when punctured with a drill bit, could escape uncontrollably and ignite. Mike Williams, chief electronics engineer on the Deepwater Horizon, put it this way, all the things they told us could never happen, happened. Since 2001, the workforce drilling for oil in the waters of the Gulf of Mexico, about 35,000 people altogether, had endured 60 deaths, 1,550 injuries, and 948 fires and explosions. Deepwater oil exploration, and drilling in particular, involves risks for which neither the industry nor government has adequately been prepared. Deepwater drillers succumb to a false sense of security, as the National Commission put it. One warning sign was the well-documented unreliability of blowout preventers. These were contraptions meant to function as last-ditch fail-safe devices to smother uncontrolled wells before they could blow. A Norwegian firm, Det Norske Veritas, published a paper that examined 15,000 wells operating between 1980 and 2006. It found 11 cases where teams drilling deep water wells, fearing a blowout, had switched on their preventer devices. In only 6 cases did the wells come under control, an apparent failure rate of almost 50%. The Department of the Interior was commissioned by West Engineering Services in 2002 and 2004 that looked in detail at the working of certain types of blowout preventers, including the one deployed at Deepwater Horizon, and found that, in many cases, the preventers did not work as advertised. The findings illustrated, the authors of one of the Interior Commission's studies wrote, the lack of preparedness in the industry to manage the last line of defense against the blowout. End quotation. 3. Current safety technology. In drilling for oil and gas, one of the major problems is lack of experienced personnel, and the other is complacency. Things are bad and getting worse, as proven by the Macondo well blowout. A lot of experienced and highly skilled personnel have retired or left the field. New hires lack insight and depth of field experience. Lack of authority to take appropriate action in the face of danger compounds this most critical aspect for oil exploration. The crew on the Deepwater Horizon was one of the most experienced and held one of the best safety records. When I considered all aspects of the oil and gas exploration, I came to an inescapable conclusion, namely oil and gas exploration in deep water is highly risky at any depth with current blowout prevention technology. Unless an automatic annular blowout preventer valve is employed with a BOP closing automatically, notifying the crew of the pressure of the kick to take immediate and appropriate action, and locking the drill pipe in drilling or tipping operation, and another disaster would be imminent. This is when I set out to design such a valve. 4. Industry efforts to improve reliability and performance. Industry efforts to redesign the shear arm as to cut the drill pipe even when excessive pressures bow the drill pipe are insufficient, adding substantial cost to drilling operations and missing the true cause of blowouts. The pressure at Macondo well had to greatly exceed the 15,000 psi force necessary to bow the heavy wall drill pipe to one side. Added to the fact that the blowout preventer was designed for 15,000 psi static pressure, whereas most kicks come on with dynamic pressure, like a raging, speeding freight train, making it extremely difficult to stop with the current technology. The Macondo well started flowing at a conservative estimate of 50 gallons a minute, entering the well bore. And by the time it reached the atmospheric pressure, it had expanded 500-fold or more and shot sky high. 50 gallons times 10 minutes is 500 gallons. Expanded 500 times, it's 250,000 gallons of potentially lethal gas mix every 10 minutes. It is extremely difficult to know what happens 5,000 or even 20,000 feet below. Everything entering the riser has to come on board. There is no other place for the expanding gases to go but up, and nothing to stop it. Every minute of uncontrolled flow is enough to blow sky high any oil platform when you consider you only need 3% to 7% hydrocarbon and air in proportion to 97% to 93% for maximum explosive power. With presently employed safety technology, by the time one activates the BOP, in many cases it is too late. 5. The CDS automatic blowout preventer. The automatic CDS BOP stops in its track instantly any kick from becoming a blowout before its gigantic mass picks up velocity, raising a multi-million-pound unstoppable force, and deploys automatically without external power and ensures the safety of the crew and equipment, notifying the operators of the presence of a kick in order for them to take immediate and appropriate degassing action. With the CDS annular automatic BOP, it is not necessary to cut the drill pipe and disconnect. After many trials and prototypes, my team was awarded patent number 9,388,657B2 for the CDS automatic annular blowout preventer, a device capable of automatically stopping any kick from becoming a blowout, or, when used in pressurized oil or gas pipelines, to stop spills in the event of a rupture. The CDS ABOP can also cut substantially the time needed to drill an oil well, since it guarantees to stop any kick from becoming a blowout, and in fracking of existing wells, it will stop methane from escaping into the atmosphere. It may also reduce the height of a traditional BOP, since it can double up as a pipe ram. The CDS ABOP works by allowing for normal drilling mud circulation between the casing and the drill pipe. At the slightest increase in flow, it closes partially, and it closes shut instantly in the event of any kick. The higher the kick pressure, the more the CDS ABOP clamps the drill pipe in its vice-like jaws of the hinged arms, and it opens automatically as soon as the unsafe pressure is relieved through the choke manifold. The now retired Wakanda Fire District Chief, Paul Gross, aware of my efforts to eliminate fires and blowouts, such as the Deepwater Horizon fire, which the Coast Guard reported to have seen from 90 miles away, agreed to test one of my prototypes. For a better understanding, we prepared a 2-minute YouTube video titled CDS Automatic Annular Blowout Preventer at the URL in the video description below. Here you will see the Wakanda Fire District pumping high-pressure water into a tube equipped with the CDS ABOP. Without the CDS ABOP, the water would have shot sky high. As soon as the flow exceeded the set limit, it closed. You can see the high-pressure water gushing out horizontally on the bottom of the stainless steel pipe, and some of the water coming from the red drill pipe, and minor prototype leaks. While the purpose of this white paper is to show the principle of how the CDS ABOP works, and not to show unfolding blueprints showing dimensions or component assembly, Steve felt it appropriate to show a picture of one of the functioning prototypes. The first picture shows the CDS ABOP opened by the internal spring. It has 5 overlapping laser-cut blades just under a half-inch thickness each, and together capable to withstand about 3,000 psi. More overlapping titanium blades with higher thickness will proportionally increase the force the CDS ABOP can withhold. The shape of the CDS ABOP is in the form of a dome because it is the strongest possible architecture. The second picture shows the CDS ABOP with the drill pipe passing through it. As the pressure and flow increases, the CDS ABOP closes much like an inverted parachute, deploying from the outside to clamp the drill pipe. The higher the pressure, the more the drill pipe will be firmly clamped until the excessive pressure is mitigated. At this point, the CDS ABOP opens automatically and drilling can resume. If the hydrocarbon industry adopts the CDS ABOP and other measures such as price stability, it will ensure the future for 50 years or more. Humanity is one more oil disaster away from losing tens of trillions of dollars in investments in the oil industry. There is no alternative to the CDS ABOP. I am convinced you are as concerned about the well-being of our environment on which all life depends and exists, and you too want to leave to posterity a planet at least as pristine as you found it. I do not know what other compelling words to use. I urge you, to the extent that you can, please do all you can to contribute and support our efforts to install the safest automatic blowout preventer in every oil and gas drilling project and pressurized oil and gas pipeline, so disasters like the Sedco 711, Deepwater Horizon, or Hercules 256, or the San Bruno, California gas pipeline explosion, and many, many others can be avoided. In this industry, an ounce of prevention is worth a lot more than 10 pounds of cure. If you are interested in purchasing, licensing, or any arrangements, or know anyone interested in our technology, or have any questions, please contact me at the email in the video description below. We greatly appreciate peer reviews. There is no doubt the invention of the CDS Automatic Annular BOP patent number 9,388,657 B2 will give you an unequaled competitive edge, set a new safety standard, and return high dividends out of all proportions. I urge you to forward this white paper to everyone you know and may be interested. Joe Levine, head of the U.S. Bureau of Safety and Environmental Enforcement, is aware of our efforts and the inherent present technology's critical aspects and imminent dangers in oil exploration, and has pledged to support once the CDS ABOP is past the prototype stage and tested under oil field conditions. We just concluded the prototype stage and are ready for test in oil field conditions. 6. Inventor background. Lastly, a few words about me and how I came to design blowout preventers. I started my career designing high-speed embroidering machines for lingerie, then managed preventative maintenance at a company with hundreds of machine tools. Before starting CD Nelson Consulting, I was in charge of quality for Westinghouse. Here I started a program called Quality Circles and introduced a program called Product Integrity for critical components where the lives were at stake. This concept changed quality control from a policing activity of finding components not meeting technical specifications and rejecting them, to a prevention program avoiding exceptions before they occur and relied on product integrity under demanding conditions. Since 1982, I've been managing C.D. Nelson Consulting. I created the trademarked Steam Shine steam generator, designed for industries where precision cleaning is critical. Because high-pressure steam is dangerous, I designed one of its notable features, a blowout preventer under the fill valve. For if anybody opens the fill valve while the unit is pressurized, it shuts down instantly and resets automatically after the danger of a blowout is mitigated. The blowout preventer feature was necessary because we sold some units to people not technically trained and also to some who use it in their homes. Demand for the trademark Steam Shine products was brisk. This is how we became a manufacturing company as well. From the beginning, we exported to many countries. After countless prototypes, hundreds of hours of research and experimentation, we sold well over 120,000 units worldwide. Success Magazine has noted our accomplishments in an article titled The Global Entrepreneur in its March 1990 issue. So truly yours, Clint Nelson, email address cn999@aol.com. Resources and credits. Special thanks to Donald and Steve for the many years of support and endurance. Special thanks to Kenny Marsh and his company, Multi-Metal Fabrication. Special thanks to Wakanda Fire District and all its leadership. Special thanks to my capable and able team and to all who contributed to this endeavor. I am very thankful to the many industry insiders for their thoughts, advice, and encouragement. U.S. Bureau of Safety and Environmental Enforcement, Joe Levine. Alphabet, Google. Oilfield Technology Exploration, Drilling, and Production. American Academy of Science, American Petroleum Institute, Stanford University, Dr. Professor Roland Horn, Offshore Technology Conference 2014 to 2017, U.S. Environmental Protection Agency, New College of Florida Associate Professor Frank Alcott, Associated Press, PBS NewsHour, CBS News, ABC News, American Chemical Safety Board, the Subcommittee on Oversight and Investigations hearings entitled Inquiry into the Deepwater Horizon Gulf Coast Oil Spill, Steve Cole, Private Empire, J. A. Turley, The Simple Truth, Joel Achenbach, A Hole at the Bottom of the Sea, Stanley Reed, In Too Deep.
It basically locks it in place. That's the idea actually. And now it goes.
That's awesome.
That's done by the pipe. Yeah, the pipe is basically like a pipe. Now, yes, the moment the pipe leaves, yes. It's a blow-up preventer for the oil industry. And not just for the oil industry, any material that cannot discharge abruptly. Doesn't matter if it's explosive or gas or oil or crude. When you see that, yeah, now it's locked and it's not going to the and of course the pipe is quick and it's locked. No. Well, this is the whole life and the get the top of the water. The water is coming actually through the center pipe.
I grabbed it off of
14 monitor.
yeah. And why I had to get it.
And we're deporting that in.
Yeah.
Yeah, but with station two, when you're on station two, bringing there, they're gonna take this. So either way,